maps with the use case number 2 of 6G-XR project, which is called routing to the best edge. It is especially relevant for latency-sensitive services like interactive media services. And what we do is to dynamically allocate optimal edge resources to minimize delay based on end-user location. There are several enablers that has been developed by the different partners of 6G-XR that are listed in this slide. And this is the overall setup. We have connected the two main testbed in the south node part of the project with Phitonic and I2CAT in Barcelona that are connected via RAID Iris and federated from the edge computing perspective. So we have that from Madrid is able to deploy over the overall continuum both in Madrid and Barcelona. And for demo purposes, we have already deployed a remote renderer in Barcelona and remote renderer in Madrid.
Okay. So the demo starts when a native holo-conference client creates a new session, calling the holo orchestrator situated here. We can see in the both web browsers that the session is already created. A native holo client will require a high performance GPU to create the session and join. And the remote renderers will benefit from having the resources, the hardware resources used in their clusters. So let's start connecting one of the remote renderers. We are simulating that the first remote renderer is in Barcelona by selecting one of the IPs of the network present there. So after a while, we will see a call to the EAIP to allocate the resource the user is requesting for. And after a few seconds, we will see that the remote renderer is joining the session. There it is. So now we use the same procedure by selecting one of the IPs in Madrid to join the same session. Let me say that for a machine like the one we are using for this demo, it would be very difficult, if not impossible, to join to the same session at the same time twice. So we see again that the response from the IP allocates the resources in Madrid, and after a few seconds we can join the same session. The graph in the top-down corner represents the latency and the difference in latency between the RPC connection between here, that we are in Madrid and the Barcelona cluster, and from directly the CPE to the cluster present in Madrid. If we watch closely, the second metric for the delay will appear, then it is. And if we move the cone a little bit, which is not a 3D object, it's a point cloud, it's a much more complex object, we can see a little bit different between the top and the bottom screen in the latency. This is not very noticeable using the browser, but when the user uses the Googles, it can even get sick about the difference in the movement and the delay.